talk about recursive functions or recursive methods. So recursion is the technique of making a function call itself. This technique provides a way to break complicated problems down into simple problems which are easier to solve. So recursion may be difficult to understand. So the best way to figure out how it works is to experiment with it. Okay, more examples, more experiments will help you understand better. So the technical information, each call of the method has its own copies of the method's variables that are kept on a stack. Okay, so um, again, the easiest way to write recursive functions is to follow some of the rules. So um, rule number one, always define one or more base cases where the method does not call itself. So the base case is usually the smallest input or inputs. So, and the other thing you should always have is this one or more ways of reducing the problem. So take the big problem, redefine it with a smaller problem. Okay, here's an example. So uh, this example will draw a n number of stars on the screen. So before we do a recursive solution, let's see how would we define an iterative solution. So draw n star basically means repeat n times and each time draw a star, right? As simple as that. But to write this recursively, rule number one is same function basically. We need to come up with a base case. Base case in this case could be when n is 1. That means that we only need to print one star and we don't need to call, the function doesn't need to call itself. So however, if n is not 1, we can say prints one star and then recursively call draw stars with a smaller problem, which is n minus 1. So assume that n is 3. N is 3 means that we haven't hit the base case. So print one star and then basically drawing 3 stars means drawing one star and then calling the same function with drawing 2 stars. So drawing 2 stars means draw one star and then call the same function with one star. One star is the base case, which means stop, print one, but no more recursive calls. All right, so another example, factorial. So factorial of an integer is, integer n is n times n minus 1 times n minus 2 times 3 to 1, dot, 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 3 to 1. So factorial is by definition recursive. So what do we mean? We mean by 5 factorial, which you can define 5 factorial as 5 times 4 factorial, right? So taking the bigger problem, redefining it with a smaller problem. So, and then that trend can continue. And 4 factorial also means that 4 times 3 factorial. So fast forward, 5 factorial is 5 times 4 times 3 times 2 times 1. Well, here the number is small. We can still track, but imagine that we need to calculate the factorial of 100. All we need to know is that factorial 100 is 100 times 99 times factorial 99, right? So, and fast forward, our in generally with factorial, our base case is when n is 1. That's the smallest input. If you ignore that 0 factor is also 0, you can also do that, but you don't have to. So we can stop at 1. So 1 factorial returns 1. Okay, so here's an example. Let's see the examples iteratively first. So fact integer n, what we could say is an iterative, we can define a result that is 1. That's the product. And then we can say while n is greater than 0, result is result times n, and n minus minus. So subtract n till n is no more greater than 0. Okay, and finally, when we're done with the while loop, we can return result. Okay, so to write the same function recursively, we could say, again, rule number one, what's our base case? Base case is n1. So if n is 1, return 1. Simple as that. So if n is not 1, we can define that n factorial with n times fact n minus 1. So, and then we put our faith into this, assuming that we'll eventually know what factorial n minus 1 is, and once we know that, we can multiply that by the original n and return. Okay, so one of the few benefits of factorial is that you almost never need to redefine a local variable, so you prevent you defining local variables or even constructing complicated loop structures. So there's no loop. Generally, there's no loop in factorial, in recursive functions. Okay, so another example. So we can use recursion to print contents of an array. So we could do this iteratively. However, it could be a lot more solid if we do recursively. So print array that takes an integer array, let's say. In this case, it will be very helpful if we have an auxiliary or a helper function called print array aux that we pass the same array with an index 0. So what might be the base case for this? This is a recursive function. So the base case for this function is, if we want to start with 0, we're going to start the element 0, right? The base case could be when we have no more elements to print. So which means that our index is equal to array.length. That's when is the base case. In that case, we can say that means we reached the end of the array, don't do anything. But otherwise, we can say print the array index, which again, first case was 0. And then we can call the same function recursively, this time with the same array, except with index plus 1. So if index was 0, now it's 1, there will be 2, there will be 3. It will eventually reach the array.length. Okay, this is how we can do that. And finally, let's look at this example. Use recursion to add all of the numbers up to 10. So how can we do that? So rule number one, define your base case. The base case would be, what if n is 0? If n is 0, return 0, right? So sum of 0 is 0. If not, how can we, if n is 10, right? How can we define a smaller problem? The biggest problem is when n is 10. The smaller problem would be 10 plus sum of 9, right? Say if they assume the name of the function is 9. So 9 is, also means the sum of 9 means 9 plus sum of 8. Sum of 8 means 8 plus sum of 7. And all the way to the end when it's 10 plus 9 plus 8 plus 7, all the way to 1. And finally, sum of 0, as we know, is the base case, which we know that will return 0. Okay, and here's how it could work. Okay, so integer sum that takes k. If k is 0, that's our base case. That means we're going to return 0. Else, we're going to return k, as in here, k plus a smaller problem than k. One smaller problem than k is k minus 1. And with this also assures that whatever the k value is, assuming that it's a positive integer, will eventually reach 0. as in every positive integer will reach 0. Okay, so if we call that with, if we call the sum method with 10, it should print 55. Okay, so that's all. And let's see more examples in the editor. Let's rework these 3 examples. Start with fact n. So again, first things again, first set up the base case. If n is equal to 0, return, or 1, right? Return 1 and done, else return n times fact n minus 1. Okay, that's the first example. Second one is the sum of n natural numbers. So in this case, we can say if n is equal to 0, this is our base case, then we can say return 0, else return n plus sum of n minus 1. Okay, so let's see if they will work. So PL, we can say fact 5, and also we can say PL sum 10. Okay, let's give it a shot. We can say, let's see if we have our recursion demo here. Okay, to make sure it's in the right place. Java C, bam, looks good. Java recursive demo. So 5 factorial is 120, and 10, sum of first 10 numbers is 55. Okay, looks like it's working. And let's see how we can do this one. So I'm going to first I'm going to define a static method called still void print array box. Okay, we can say helper. Okay, that function takes another integer array and an integer I, short for index. Okay, so in this case, it's very difficult to rewrite this recursively, so we need a helper function. So we're going to use the helper function by calling print array helper with the same array with 0 as the first index, and this function, which is the recursive, will so again, the base case is if I, which is the index, is equal to array dot length. Okay, if that's the case, we're going to not do anything because we can't. Else we can say now we need a block. We can say PL. We're in a good place where we can actually print the first element of the array, and I will say array of I, right? Let's make it print, and maybe plus a space, that's to our liking. Okay, and then I can call print array helper with the same array, except that we're going to increase I by 1. Okay, so imagine we'll start with 0, then 1, then 2, then 3, then on. Okay, so let's see if this will work. I'm going to create an integer a, let's call it a, which will be 1, 2, 3, 4, and 5. Then we need to call print array function with a. So hoping that it'll work. Call seems like okay. Here we go. So 1, 2, 3, 4, 5. One thing we might do is when we're done, where should we be? Either here or here, we can do one extra print. So I'm going to say probably not here, because we're going to, if it's in here, we're going to keep printing empty spaces. But if it's here, we should be good. That means we're only going to do this one time. Just to make sure it's clear. Demo Java. Okay. So one